Hello everybody, so today we're dealing with Trigonometry chapter 22, exercise 22e, question number 21. So this question says as that you have to answer the opening problem in the start of the chapter. So this opening problem states that a group of students is asked to measure the height of the gymnasium. It is a symmetrical building, so if this is the altitude of the building, then this divides into two equal parts as shown. From a point 32 meters from the side walls, this is a side wall 32 meters, the student measured the angles of elevation to the top of the side wall and to the top of the roof. Now we have to calculate how high is the side wall of the gymnasium, what is this length, and what is the length of the top of the roof, so what is this length, and then we have to calculate the angle theta. So we can start by looking at the first thing, that is the side wall of the gymnasium. So we can label them as, we can label this A, label this as B, this as C, D and E. So we can say that in triangle ADE, angle ADE, that's angle ADE is a right angle. If this is a right angle, then we know that we can use trigonometry, and then we can use SOHCAHTOA. So we're dealing with if this is the theta degree angle, so this is the opposite and this is the adjacent. So we know the adjacent, we know the angle, so we can calculate the opposite. So we will use here TOA, that is tan. So we're going to say tan 14 degree is equal to AD upon ED, that is opposite upon adjacent. That is going to give us AD upon 32. From here we can calculate AD as around 7.98 meters. So this is, I forgot to mention, this is a first part. Then I'm going to move on to the second part of the question, which asks us to find BC. So BC here we can calculate from the bigger triangle, that is in triangle EBC. Angle BCE is a right angle. So again, if it's a right angle, we can use trigonometry and then again tan theta. So we're going to say tan 16 degree is equal to opposite, that is BC, adjacent, that is EC. Now here we can say that EC is equal to DC plus ED. Now DC here is 12 meters because it's a symmetrical building, so it divides into two equal parts, so 12 and 12. So this is 12, so we're going to say BC upon 12 plus ED is 32. That will give us BC upon 44. And then we can calculate BC from here, which is around 12.62 meters. From here we can calculate BO if we name this point as O. But yeah, we're going to move on to the B part of the question, which asks us to do exactly this. It asks us that, can you find the angle theta? So if we have to find the angle theta, then we can use tan theta, because we know BO if we calculate BO by using BC and AD, and we know AO because we know DC. So we can just say that, yeah, we can calculate angle theta, and in fact tan theta is equal to opposite upon adjacent, that is BO upon AO, and BO is equal to BC minus AD, and AO is equal to DC. So BC minus AD is going to give us around 4.64 meters, and then we can just write as DC as around 12 meters. meters. So we don't have to write meters here, so we can just say theta is equal to 21.64 degrees, and that's the answer. So thank you.